November 1st, and this is the first thing that we did in class today. So this is 11.1. And we were looking at yesterday using the PhET simulation to balance equations. So today we're taking that information and we're trying to do it on pencil paper instead of the PhET simulation. So the first thing that we wrote down is the law of conservation of matter. And the law of conservation of matter states that matter is never created nor destroyed, it's only transformed. So in class we talked about what that means, and chemical equations are models that show matter is not created or destroyed, because all the atoms on one side of the equation have to equal all of the atoms on the other side of the equation. So the mass, or the matter, that's on one side of the equation has to equal the other side, has to balance. And then together we did this sheet on balancing chemical equations, and you can pause here. The first thing that it said to do was to circle each subscript. So we went through and circled the subscripts and draw squares around each coefficient. So we drew squares around the coefficients. And then we answered the question. So what does O stand for? Oxygen. How many carbons? 1. How many oxygens? 2. Now, this is where we started, not to say new stuff, but just to realize what we did. We've got a coefficient of a 5 and a subscript of a 2. So how many atoms of hydrogen are in this formula as shown? And it's 10, because what you have to do is you have to take the 5 times the 2. 5 times 2 gives me 10. My coefficient times my subscript. If you think about what this was yesterday when we were doing the PhET simulation, every time you change the coefficient, remember you could not change hydrogen. That's what a hydrogen molecule would look like, 2 hydrogens together. So every time you said you added 1, so that would be 2 H2 molecules, and 3 H2 molecules, and 4 H2 molecules, and 5 H2 molecules. So if I have 5 H2 molecules, each circle is an atom. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is how we can do our coefficient times our subscript to get how many atoms that we have. So on a little bit longer journey here, we have 2 elements. So the 2, that's the coefficient, is applied to the carbon and it's applied to hydrogen. If you remember the distributive property in math, where you take the number outside the parentheses and give it to everything inside the parentheses, that's the same concept that's happening here. You take the coefficient and it applies to everything in the chemical formula that's attached to it. So for carbon, the 2 times the 2 gives us 4, and for hydrogen, you can see we have 12. 2 times 6 is 12. Same thing here. 2 times 2 for sodium, 2 times 1 for sulfur, and 2 times 4 for oxygen. Then we labeled at the bottom, it says reactants right here. So these are our reactant side because these are the things that are reacting. The arrow means yields, also means the same thing. It's like, could mean equals. Pretty much the same thing. It's showing you what these two things, when they react, what they make, what they produce. So what do they yield? Over here you have the product, 2 magnesium oxide. So you have magnesium plus oxygen gives us 2 atoms of magnesium oxide, or 2 molecules, excuse me, of magnesium oxide. This number here is our subscript, and this number here is our coefficient, which is review. Then underneath there in our notes, what we talked about was the mass and the atoms in the reactant must equal the mass and the atoms in the product. So when you have a chemical equation like this, you can see here I have 2 magnesium atoms on this side and I have 2 magnesiums on that side. I have 2 oxygen atoms here, and since this 2 applies to everything, I also have 2 oxygens over here. Then we have a practice page that we did together. The first side of it we did together. The second side we worked in groups and kind of worked on our own and self-checked. So we did some practice. So I'm going to work out all of these with you really quickly. So you can fast forward and go through, speed up. I'm going to work all of them for you and upload it. So what I'm going to go pretty quickly so we can do this. So we've got hydrogen on this side and chlorine on this side. You will also notice that you have hydrogen and chlorine on the second side. So what you have to do is, if you think these are all one coefficients, you have to take an inventory or account of what you're beginning with. So on this side I have 1 hydrogen, 1 chlorine. On this side I have 2 hydrogens and 2 chlorines. So if I'm wanting these things to balance, the only thing I can change is the coefficient. So the coefficient here, because I cannot change subscript, I cannot change my elements, I can only change the coefficient. If I have more on this side than this side, that means I have to add over here. So this is my reactant side. So if I change this number to a 2, which is what I'm going to do, then I'm going to have 2 hydrogens and 2 chlorines. And then I self-check. Hydrogen is 2, hydrogen's 2, chlorine's 2, chlorine's 2, and I am balanced. Let's look at the next one. You have nitrogen and iodine. If I have one of those, which is what I always start with, I have 1 and 3 atoms. On my product side, I have 2 nitrogen atoms and I have 2 iodine atoms. So if I look here, nitrogen's out of balance and iodine's out of balance. So I'm just going to pick nitrogen and try to balance it. So this nitrogen on this side, if I change that to a 2, that becomes a 2. However, this nitrogen is attached to this iodine. So this iodine is going to change to 6, which is fine. Over here I have 2, and now my iodine's out of balance, which it was to begin with, so that's fine. So I look over here and I make this try to equal 6. Well, I know that 3 times 2 will give me a total count of 6. So now I'm balanced there. Potassium and sulfur. If I have 1 potassium and 1 sulfur on that side, I have 2 potassiums and I have 1 sulfur there. The only thing that's out of balance is potassium. So if I put a 2 here, it becomes 2 and 2, and I'm balanced. Aluminum and iodine. I have 1 aluminum and I have 2 iodines. On this side, I have 1 aluminum and I have 3 iodines. So I have to look at how I can get the subscript 2 and 3 to become equal, and that's really hard to do. If you think about something called the least common multiple, I can have these guys, these have both the common multiple of 6 in common. So if I change this to a 3, that becomes 6. If I change this to a 2, then my iodine becomes 6. But in doing that, I knocked my aluminums out of balance, because remember that 2 goes to both things. So you have to recount. Every time you do a coefficient, add a coefficient, change a coefficient, you have to recount. So by knocking my aluminum out, I have to come back and put a 2 here to make sure that my aluminums balance, and they do. The bottom one, I've got 1 aluminum, remember this is number 5, and I've got 1 sulfur. Over here, I have aluminum, I have 2, and sulfur, I have 3. So this one's pretty easy because over here they're apart. So if I just put a 2 here, that makes me have 2 aluminum, and if I put a 3 here, that makes me have 3 sulfur. So I'm good to go. Balanced. All right, on the back side, number 6, I've got nitrogen and oxygen. This one is a little bit different because, I have 1 nitrogen, got ahead of myself, and I have 3 oxygen. Now, how I got 3 is because I have 1 in the the nitrogen monoxide, and then I have 2 over here with just oxygen. So I have to add those together. 1 atom here and 2 atoms here gives me a total of 3 atoms. On this side, I have 1 nitrogen and I have 2 oxygens. Now you might think, oh, well, we just put those to 6, but this oxygen is split. So my goal is to get this side to an even number, because you know this side will always be an even number because you're multiplying by 2. Whatever you put here, you're multiplying by 2. So if I can get this to be 4, that's just where you kind of start, and it's just, again, it's a guess and check method. If I change this to 2, I then have 2 nitrogens, and remember that 2 goes to the oxygen, so I have 2 oxygens here and 2 oxygens here. So 2 and 2 is not going to give me 6. A lot of people want to say 6. It's going to give me 4. 2 here and 2 there. Now my nitrogen and oxygen over here obviously are not working, so I have to put a 2 here, and then I get 2 and 4 because the 2 goes to both. And 7. Sodium, I have 2. Oxygen, are split, I've got 2. Hydrogen, I have 2 on my reactant side. On my product side, I've got a 1 sodium, I've got 1 oxygen, and I've got 1 hydrogen. 1, 1, and 1. So this side needs more to balance this side. So I'm going to put 2, and those all change to 2, and I'm balanced. The next one, CH4. I've got 1 carbon, I have 4 hydrogens, I have 2 oxygens. One of the things is, do you notice how oxygen comes second and hydrogen comes third? I like to list them in the same order on both sides so that you can look straight across. So carbon is 1, hydrogen is 2, oxygen is 3, 2 and 1. So this one, my oxygens are out, but so are my hydrogens. So I'm going to deal with my hydrogens first, just because I am going to. So on this side, if I get my hydrogens in balance, if I put a 2 here, that will change my hydrogen to 2. I mean, sorry, it won't either. I lied. It'll change it to 4. 2 times 2 is 4. All right, so my oxygen then, because I have 2 oxygens here and 2 oxygens here, my 3 will also become a 4. So then I have to come back. My carbons are balanced, my hydrogens are balanced, my oxygens are not. If I place a 2, and I can leave those as 1s, if I place a 2 here, that becomes 4. And I'm done with 8. All right, lead oxide and carbon will give me lead plus carbon dioxide. So if I have 1 of each of those to start off with, my lead is 1, my oxygen's 1, and my carbon's 1. On this side, my lead is 1, my carbon, I'm going to put oxygen second though. My oxygen's 2, and my carbon is 1. And I like to list them in order, the same order on both sides. It doesn't matter the order, but the same order just helps me to see. So the only thing that's out of balance is my oxygen. So this one needs more oxygen. So let's put a 2 here, and that becomes 2. However, it also changed my lead, because don't forget the 2 is applied to oxygen and to lead. So over here, I have to change this one to 2, which will change this one to 2. And now I'm balanced. Over here, I didn't give you the space to do your inventories, so I'm going to use a piece of scratch paper. If you can do these without scratch paper, that's fine. You don't have to necessarily show your work. If you're getting confused, you need to show your work. So right here, I'm going to do the same thing, and I'm going to just put me a line right here on my scratch paper, and I'm going to list what I've got. I've got 1 iron, and I've got 1 chlorine. I've got 1 iron, and I've got 3 chlorines. So I have to change this to a 3, and I'm balanced. Number 2. Just making my line. I've got zinc 1, hydrogen 1, chlorine 1. I have zinc 1, hydrogen 2, chlorine 2. So my zincs are in balance, my hydrogen and chlorine are not. This side needs more. So if I put a 2 here, that brings my hydrogen to a 2 and my chlorine to a 2, and I'm balanced there. I look at number 3. I have calcium and oxygen giving me calcium oxide. So I have 1 of each of those to start with. So my calcium, oops, I'm going to draw my line. So I have this divided into 2 parts. I have 1 calcium, I have 2 oxygens, and I have 1 calcium, and I have 1 oxygen. So this side needs more. So I'm going to make this a 2, and that's going to change my oxygen to a 2, but it also changed my calcium to a 2 because they're attached. So I have to come back over here, and now that's a 2, and I'm good to go. Number 4, I have nitrogen and hydrogen giving me nitrogen trihydride. So nitrogen on this side, if I do a 1 here, I have 2 nitrogens, I have 2 hydrogens, and on this side I have 1 nitrogen and I have 3 hydrogens. So in this case, nothing splits, so the 2 and the 3, you can try to get them to their least common multiple of 6. So if I do that, if I put a 2 here, I end up with 2 nitrogen and 6 hydrogen, which is good because my nitrogen then balanced. My hydrogens are still out of balance because I have to put a 3 here to make that a 6, and then I balance out. Number 5. Number 5 has copper oxide plus carbon to give me copper and carbon dioxide. So if I break this down, I have copper of 1, oxygen 1, carbon 1. Copper 1, I'm going to do oxygen next, 2, and then carbon is 1, even though it's not in that order in the line, so I can keep them straight. So I can see my oxygen is out of balance. So if I change this to a 2, that becomes a 2, but so does my copper, because copper and oxygen are attached. So on this side, I have to change that to a 2 to make that a 2. So then I'm balanced. Number 6. This is hydrogen peroxide or dihydrogen dioxide. So giving me water and oxygen. So I have 2 hydrogens and I have 2 oxygens. I have 2 hydrogens and I have 3 oxygens. Now, the thing about this is, remember, your oxygens are split, so I don't want to try to go to 6 yet. I want to try to get this even over here. I'm going to try to go to 4. So if I put a 2 here, that becomes 4, and then that becomes 4, because remember, that's a 2 oxygen here and 2 oxygen here, giving me a total of 4. On this side, I have 2 and 2. Well, I can easily make that 2 and 2 because they're connected. If I place a 2 up here, they each become 4, and I'm balanced. All right, number 7. I have sodium plus magnesium fluoride. So if I do this and get my counts, sodium is 1, magnesium is 1, and fluorine is 2. Sodium is 1, magnesium is 1, and fluorine is 1. So I need to get my fluorines in balance. So if I put a 2 here, that changes fluorine to 2, but it also changes my sodium to 2. So I have to come back over and change to 2 and 2, and I'm balanced. All right, number 8. Magnesium and hydrogen chloride, or hydrogen monochloride, I guess that would be, and then magnesium dichloride, nope, I lied, magnesium chloride and hydrogen. That's an ionic bond, I don't use my prefixes. Alright, so if I put 1s in here, magnesium is 1, hydrogen is 1, and chlorine is 1. Magnesium is 1, I'm going to do hydrogen next. Hydrogen is 2, and chlorine is 2. So my hydrogen is obviously out of balance, and so is my chlorine. So if I come back over here, they need more. So if I put a 2 in front of my HCl, I get 2 H's and I get 2 Cl's, which solves both of my problems in one step. So I'm done. All right. Let me do number 9. All right, I've got Cl, which is chlorine. I have 2 of those. I've got potassium and I've got iodine, 1 of each. On this side, I have Cl, which is 1. I have potassium, which is 1, and I have iodine, which is 2. So I have to come over here and make, or I can come over here, doesn't matter, whichever one. I need 2 chlorines, so if I change this chlorine to 2, that becomes 2, and my potassium becomes 2, because they're attached. So then I need a 2 here to make my potassium 2 and my iodine 2, and then I'm balanced. All right, the last one on our practice together. Let me get a clean sheet. I'm out of scratch paper. If I look at this one here, oh, I can probably do this one right underneath here. If I break this in 2, I have sodium and chlorine, which is salt, sodium chloride. I have 1 of those, 1 of each. And then that's going to give me sodium, which is going to be a metal. So I have one of those, and I have chlorine gas. So I have 2 of those. So that's automatic. So what I need to do is, obviously I need 2 chlorines over here. So if I change this to a 2, that becomes 2, but it also changes my sodium. And if I come back over here, I change that to a 2, and now I'm balanced. That's how you balance chemical equations. It's a guess and check method. We're going to do more practices like this in class. So feel free to look up other tutorials. Khan Academy is great, KHAN. Look on my YouTube channel. You can find some more practice.